Hello, I am Brian, and we are going to see now how to create hello, I am Brian, and we are going to see how to create a custom loss using Keras. You can find me out in these links over here. Probably are going to be here. So the motivation for creating a custom loss is in case you want to create an architecture similar to the Inception architecture from Google. In this case, it has like 1, 2, 3 number of connections to the final layer, that is the output layer, and using Keras in the sequential way you cannot do this, or at least I don't know how to do it in this way. So the way to actually create this is by using the functional API from Keras, but it still is that you have to join together some kind of information in order to actually make this work. So the goal of this tutorial is to create a simple architecture like this one, similar to, where we have some number of hidden layers. This is going to be the output layer, the target, and actually what we are trying to do here is this. The middle layer of the hidden layers is going to have like a direct connection to the output layer, and therefore it's supposed to be more efficient in the backpropagation process, because you don't is more direct here. It is similar to the residual networks, residual blocks, also for convolutional neural networks, because it has this connection directly, but this in this case is a little bit different. So this is the purpose, and let's go for it. Here I have to clean this. We specify here we don't actually need pandas, we don't need OS, pyplot, not yet. From here we don't need the sequential model, everything else yes. In this first section we specify we create our data. We are going to create an array of number of samples, 100 by 10 features, input features, and the number of output features only 1. We are going to work with a regression problem. Then we create a random distribution with a mean of 0, standard deviation of 1, and the target is going to be the summation of the addition of the second and the fifth column variables, features. So with expandims we are reshaping it from a flattened variable to 100 by 1. And here is the main concept. Here are. So in contrast to a sequential model, when you are working with this custom loss in a functional API, you have to define the input for the your input features and your output feature or your target. Otherwise you don't have how to manipulate these outputs to make the previous architecture. So first of all we define these two. Over here we are defining just the learning rate. L1, 2, 3, n are the number of hidden units of the hidden layers. So first, the way to connect with the functional API is that you create in this format what is going to be connected to this specific layer. So we are connecting the input X towards this dense layer. We create a batch normalization. Here is the difference. In the second one, we are also creating a dense layer. However, it is going to have another output. So we are making, if we have the layer 2, we're adding another matrix here that is going to translate, or actually is going to work in the following way, from 2 features that has this layer 2 to 1, because we need to match the number of the features of the output layer of our target. And we are using a linear activation since we want to make this a regression problem. Later we continue with the specification. Take note here that we are not connecting L2O, that is our output that is going to be connected directly to the output layer or to the target. We are using L2, that is one step before here. So next we continue adding a new layer, add generalization, and finally this is going to be our output layer that has the same number of features of our target. So here we have our custom loss, that is going to be the absolute difference between the output of our second layer plus the output or the final layer, of the difference, or the absolute difference between our target and the final layer. And we are making a summation, an addition over all the differences. So it's not only the mean, we're taking the summation of everything. And here we have to specify the inputs that we defined, how many inputs we are expecting to receive into the model, and the number of, or the outputs we are expecting. For instance, here we only want that this function is going, or this model is going to throw the final layer outputs. We will specify also an array, or a list, actually a list, where we are defining that the final layer and the output of the layer 2 as the outputs. In this way we later could work with a custom metrics to see how this is behaving with our customized architecture. So finally we have to add explicitly the loss and just the standard steps here for the optimizer and compile. So time for training. Here is not the core of this video, but we are basically specifying some lines for the split of training and testing, the number of iterations, how the interval to evaluate the validation set, the training set, the batch size. In the first section here we are making the split of training and testing, and during the iteration process we are splitting, or actually sampling, a number of samples from the training. For making the train we are using train on batch. Take a look here that we are specifying the X train, Y train, that is actually and we actually have to improve this, because we should mean X train B, that is referred to the batch, because here we are sampling. We don't want this to be overall, even though that's a small number of samples. It's just to keep this format for a bigger number of samples that we could have in another problem. So the important thing here is that we are adding this none, because train on batch is going to